Kásán, ẹ kú ojúmọ́, ẹ káalẹ́ fún gbogbo ibikíbi tí ẹ bá ti ń wò wá. Ẹ̀kọ́ tí a fẹ́ kọ́ lónìí ó ṣe pàtàkì gan, ó dẹ̀ ṣe kókó. I've said it in most of the classes at which we've had together. I said by the time at which we are going to be talking about hybridization, it is very, very important topic at which we're supposed to know or we have to know. It is the topic at which that precedes the understanding of organic chemistry 1, or let me say it aids the understanding of organic chemistry 1. Kí ni mo gbìyànjú àti sọ náà ni pé tí a bá ti fi lè mọ ohun tó ṣẹlẹ̀ ní hybridization, ó máa yá wa lára láti lè mọ ohun tó ṣẹlẹ̀ nínú organic chemistry 1. So organic chemistry 1, organic chemistry tí ẹ̀ ní lè fún wa rárá. So ó ṣe pàtàkì fún wa láti lè farabalẹ̀ ká dẹ̀ kọ́ ẹ̀kọ́ yìí. Okay, let's go. Tá bá sọ̀rọ̀ nípa hybridization, hybridization is from the word hybrid. Hybrid. Kí la lè pè ní hybrid? Ká mú nǹkan méjì tí ò jọra wọn tàbí nǹkan mẹ́ta tí ò jọra wọn ká wá lẹ̀ papọ̀ kó di nǹkan ẹyọ kan. Ní tí a pè ní hybrid nìyẹn o. Hybrid, from the knowledge of computer, or tí gbogbo wa mọ̀, every one of us will know what computer is. Computer. In the olden days, it wasn't the computer that they are using now or we are using now. It's not what they were using then. There is something called analog computer and there is something called digital computer. Now, presently as we have something called hybrid computer. An hybrid computer is the one that have the features of both analog computer and digital computer. So that is an hybrid. Hybrid computer will possess or will have what we call the characteristics of both the two computers. So tá bá wá sọ̀rọ̀ nípa hybrid, ká mú nǹkan méjì, bringing two different things together, combining them together to become one. In the knowledge of biology also, we have what is called hybrid. That is when we have ejeka wolison a lè mú cowpea kan tó ní irun lára tó ṣèso dáadáa, but time tó tètè máa ń wù kò pọ̀, time tó tètè máa ń wù ó pọ̀ gan-an. Àwọn tó ní another form of cowpea tó ṣe pé òun ò ní irun lára kò dẹ̀ kí tètè ó dẹ̀ ó wá time tó wá máa ń wù, time tó yẹ pé ó kéré jọjọ. Àwọn mú cowpea méjèèjì yẹn àwa ṣe wọn ní tá à ń pè ní crossbreeding. Àwa crossbreed bẹ́ẹ̀ yẹn ohun tó máa jẹ́ ní tó máa fà fún wa ṣe lẹ́sẹ̀ A and B. Tábà wá crossbreed àwọn méjèèjì ní tá a máa produce is hybrid. Now láti tó wá lè jẹ́ kí hybrid kó tó yé wa dáadáa, a bá sọ̀rọ̀ nípa hybrid so that a máa lè ti ní òye ibi tí mo lọ gangan. Now ká tó wá lè ní òye hybrid dáadáa, èmi àti ẹ̀yin, we are as the result of an hybridization. We have our father and we have our mother copulating together to produce an offspring. That offspring will possess or have the features of both the father and the mother. The offspring is actually what we call an hybrid. It's what we refer to as an hybrid. So with this, I believe we have the knowledge of what an hybrid is all about. So that is what we call hybrid. So that is the knowledge of, so let's have that knowledge of what an hybrid is as such. Now let's now come back into chemistry. When by the time we will be talking about the hybridization of chemistry, and the elements at which we will be using mostly. Nítorí pé carbon òní element tá máa ń lò ní organic chemistry is the let me say òní ọ̀nà lójú is the central atom of any other compound. Other compounds can come and join it, but in every organic chemistry we must have a carbon atom. So carbon atom òun gangan ààrẹ láti bẹ̀rẹ̀ hybridization. So let's say for example now we have carbon with atomic number of what? 6. The electronic configuration of carbon atom is 1s2, 2s2, 2p2. Electronic configuration, not electronic structure. When we are talking about electronic configuration, that is when we use our SPDF orbitals. If we are talking about electronic structure, that is when you'll be using your KLMN shell and you'll be having it to be in this form. So structure and configurations are not the same thing. So now let's have it this way. I believe we understand it. So let's have 1s2, 2s2, 2p2 to be our electronic configuration for carbon atom. Now carbon atom as it is here, we have, that means S can take 2 electrons, P can take 6 electrons. Okay, yes, we've gotten the understanding. I explained it in the previous classes how the number of electrons at which each orbital can actually take. I believe we know that. So S can take 2, P can take 6, D can take 10, and F can take 14 electrons. Now that means for every orbital at which we also have what is called suborbital. Suborbital. That means bó ṣe wà yìí, ẹ jẹ́ kí n kọ́ dáadáa kó lè yé wa. We have S, P, D, F. So we have 2, we have 6, we have 10, and we have 14. We now have what is called suborbital. This is orbital 1, 2, 3, 4. I said we have what is called suborbital. The suborbital of S is 1. Suborbital of P is 3. So we have it to be Px, Py, and Pz. Px, Py, Pz. The likes of orbital D, its own suborbital is 5. One, two, three, four, 5. 1, 2, 3, 4, 5. So we have it to be dx, we have dy, we have dz, we have dx squared, and we have dx minus dz. 5 in it. The same thing we have for F orbital. That one is 7 suborbitals. Now, again, now that means for 2p orbital of our carbon, actually that is here, it is what? We have it to be 3 suborbital, I mean for p orbital. So we have it to be px, py, pz. Now, electrons mélòó ló wà lórí p orbital yẹn? Now 2s wà náà bó ṣe rí ni. Ṣàbí mo sọ lẹ́ẹ̀kan mo ní s orbital subshell kan lòun ní. That means òun ní 2 electrons. And 2 electrons yẹn ó ní mo ti represent by this. Mo represented by nǹkan tá à ń pè ní spin. Spin. There is a particular rule. Rule kan wà tó yẹ pé a máa ń follow in this hybridization. Rule yẹn ó gbọ́dọ̀ máa bá lọ in arrangement of electron in an orbital. Kí ni àwọn rule yìí? À ń pè rule méjèèjì ní Auerbach principle and On's rule. Now, principle and this rule, it is our guidance that is helping us in knowing how we can arrange all these spins at which we use to represent electron in the shell or in the subshell. Ṣé nǹkan tí mo rán mú díẹ̀ kó lè máa yé wa? Now, kí ni On's rule ló sọ? What On's rule is saying is that in the degenerated orbital, degenerated, náà là ń pè ní suborbital. In any degenerated orbital, the spin electron must be arranged first accordingly. Kí ni nǹkan tí mo try láti sọ pé bí nísìn in degenerated orbital ṣe ń pè s orbital, degenerated orbital or suborbital ẹyọ kan péré ni. Now bó ṣe jẹ́ ẹyọ kan yẹn electron mélòó ló wà ní electron méjì náà, so méjèèjì ni. Now On's rule náà ló tó wọ́n sọ fún wa wípé spin méjèèjì the electrons must be in pair. Now, if they are now in pair like that, they must now be in an opposite direction. Being in an opposite direction like that. So now this is another degenerated orbital P, in which we have to be Px, we have Pz, and we have Py, and we have Pz. But how many electrons la ní níbẹ̀? A ní electrons méjì. A ní electrons mélòó? Electrons méjì. Now that means a máa wá lo spin láti fi lè represent electron méjì yẹn nínú suborbital. So wọ́n máa rí báyìí. Me, to follow what untrue is, I cannot just say 2 here. Tí mo bá tún lè sọ pé 2 ní níbí náà, ó jẹ́ wrong. Ìtí àwọn principle wọ́n sọ pé in any degenerated orbital, agbúdọ̀ kọ́kọ́ fi sí lẹ́yọ kọ̀ọ̀kan lọ́nà sequentially, agbúdọ̀ kọ́kọ́ fi sí lẹ́yọ kọ̀ọ̀kan kó tó wá di pé a máa padà wá máa complete it because they must be in pair. Kó tó wá di pé a máa padà wá máa so méjèèjì ó gbúdọ̀ lọ bá gbé px py so tẹ́lẹ̀ tán ní ìbámu wà pz ní máa fi sí kì í ṣe pé màá sọ pé px máa fi méjì sí straight máa fi sí bẹ́yẹn rárá bó ṣe kó rí kọ́ nìyẹn. Now at this state bí carbon atom bó ṣe rí ní bá ṣe represented so 2s ní carbon atom ó ní 2p carbon atom ó ní yìí. At this state carbon is at the state of ground state. Kí ni mo pè o? Ground state. So carbon is at the ground state here. Now, this is p orbital, px, py, pz. In this case, carbon is not vulnerable, neither being susceptible in order to give room for any other any other element or molecule to combine with it. Now, kí ni mo gbìyànjú àti sọ pé kò tí ì lè fààyè gba ara rẹ̀ láti lè jẹ́ kí àwọn any other element tàbí molecule kí wọ́n máa combine pẹ̀lú ẹ̀. Now ẹni tó máa sọ fún bóyá àwọn wò pé àwọn ní carbon 4 oxide náà a ní carbon 2 oxide lóòótọ́ ni. It is actually at the excited state of carbon atom òun ni oxygen tó lè combine carbon láti bí lè di carbon 2 oxide or kó lè di carbon 4 oxide. Kí wọ́n ní à ń pè ní excited state? Ìgbà tí electron kan tó wà ní ara these two s orbital ó máa move ṣe ti pé s àti b wọ́n ti wá àti mú amúlára s electron tó ń bẹ lára s àti mú àfi sí b. So now wọ́n á máa báyìí carbon with 6 electron so 1s2 2s2 2p2. Now this is p orbital suborbital like this. We have it to be this. Now the s orbital tó jẹ́ méjì àwọn máa mú ẹyọ kan bẹ̀ a máa pa ilé rẹ̀ báyìí. So ẹyọ kan yìí àwọn máa transfer kó a máa lọ báyìí pam pam pam. So ó ti wá jẹ́ pé ó ti di mélòó? Ó ti di mẹ́rin. 2s ó ti di ẹyọ kan, 2p ó ti wá pé mélòó? Ó ti pé mẹ́ta. Now at this state we call it excited state. Excited state of carbon atom. Now, what do we mean by the excited state of the carbon atom? This is the time, this is the period at which the susceptibility of carbon atom can actually be assessed. Kí ni gbogbo ìbò tí mo sọ? Ó lè ní pé àsìkò yìí òun ní any other element ó lè bond pẹ̀lú carbon atom. Now, we now have kí wọ́n ní types of hybridization dání ẹ̀wá jẹ́ káàró ṣe pé a ti mú lára tó ń jẹ́ s àti ilẹ̀ mọ́ p, that means a ti mú nǹkan méjì tí ò jọra wọn àti ilẹ̀ papọ̀. What belongs to s àti gbé wá sí p, that is hybridization. So we can now have types of hybridization. We can have types of hybridization to be sp méjèèjì. We can have it to be sp, we can have it to be sp2, we can have it to be sp3. Ẹ jẹ́ ká farabalẹ̀ dáadáa kí ibi báyìí lè lè wà. Mo ní any types of hybridization to be sp, I want it to be sp2, I want it to be this s orbital to be sp3. Now, kí ni a pè ní sp? sp ní ìgbà tí, let's say for example hydrogen ó wá lẹ́mù carbon atom, hydrogen molecule, hydrogen is a diatomic element, ó wá lẹ́mù carbon atom. That means bó ṣe wá lẹ́mù carbon atom yẹn o, ẹ jẹ́ ká wá wò electron mélòó ló kù lẹ̀, ó kù electron méjì. Space mélòó ló kù lẹ̀, that means px then e, this is px, this is py, this is pz, and this is s. So tá a bá ní pé s and tí hydrogen bá ti wá wá bẹ́yìn, hydrogen with hydrogen molecule, that is 2 electrons, ó máa lẹ̀ mọ́ bí, ó tún máa lẹ̀ mọ́ bí, that is spx. So sp is spx. That means we will now have 2 unbonded electrons. Ní nǹkan míì mọ́ tó tó lẹ̀ mọ́, 2 unbonded electrons. So in this case, in sp3, in sp hybridized, we will be having 2 unbonded electrons. 2 unbonded electrons. 2 unbonded, what's it called? This is 2 pi bonds, rather. So the electron can be by. Bó ṣe wà yìí báyìí, ó wá máa jẹ́ irú sp3 sp hybridized yìí, ó náà wá need to be triple bond, triple covalent bond. And people like that máa ń rí eléyìí to be triple covalent bond. Example, a máa ní wọn to be alkynes. Àwọn tí wọ́n ní electrovalent, I said electrovalent, covalent bond, sorry, we have it to be covalent bond, meta. One of them, I will tell us. Now, this is a bond, this is a bond, this is a bond, but there are different types of bond actually. So this is an alkyne. In alkyne, we will sp3 hybridized. Whereby, and what is the example of that? Let's say for example, alkyne molecule, we can have it to be ethyne, which is C2H2. Check it pé hydrogen méjì péré ló lẹ́mù carbon atom. Hydrogen méjì péré. So with that, we can have the structure to be like this. H. This is what we are considering C triple bond C. So the type of hybridization to one be by E, it is sp hybridized. It is sp hybridized. Now, tí hydrogen ní ìbá tó wá lẹ́ẹ̀mọ́, ó ti di sp2. sp2, that means àtúntò ní ìlà. Don't forget, according to Earth's rule, it must be, the spin must be in an opposite direction. So, tẹ́lẹ̀ bá wálẹ̀, tẹ́lẹ̀ bá wà lókè, tẹ́lẹ̀ bá wálẹ̀, tẹ́lẹ̀ bá wà lókè, tẹ́lẹ̀ bá wálẹ̀, tẹ́lẹ̀ bá wà lókè. So, àtúntò ní ìlà tó ti lẹ̀ mọ́. In this case, we can have this one to be double covalent bond. This is triple covalent bond. This is double covalent bond. And we can have this one to be in alkenes. Alkenes, láti lè ní ẹlẹ́. And an example of an alkenes, we have it to be ethene, that is C2H4. We have that to be double bond. So hydrogen comes to the lemon. Hydrogen comes to the lemon. So the type of hybridization at which we are having here, in C double bond C, it is sp2 hybridized. So on the sp2 hybridized, we have it to be alkenes. And they have their own respective features. And now, for the sp3 hybridized, hydrogen is going to lemon. sp3 hybridized. So in that case, we have it to be just an ordinary single bond. And we have that one to be an example of alkanes. And in an alkanes, example of that alkane at which we have is methane. So we have alkanes. And we have CH4. Sorry, we have it to be CH4. So we have this, we have this, we have this, and we have this. You can see it is just a single what? Covalent bond. Here we have it to be double covalent bond, sp2 hybridized, sp hybridized, we have it to be triple covalent bond, sp3 hybridized, we have it to be just a single covalent bond. In lieu of this, nípa gbogbo eléyìí láti mọ̀ yìí. In the next class, màmá sọ fún wa àwọn features àti àwọn bí wọ́n ṣe máa ń béèrè lórí àwọn hybridizations yìí. Mo máa sọ features sp hybridized fún wa, mo máa sọ features sp2 hybridized fún wa, mo máa sọ features sp3 hybridized fún wa àti àwọn compounds tí wọ́n lè exhibit irú wọn. àti pé ní ìparí mo tún máa sọ fún wa tá a bá kọ compound kalẹ̀ bí irú nísìnyí kí n kàn kọ, let's say for example ok compound kan yìí bá ẹ jẹ́ ká wo compound kan yìí bá compound yìí. Bóyá fún àwọn tá a fẹ́ kọ JAMB or akẹ́kọ̀ọ́ WAEC wọ́n lè fún wa ní irú compound báyìí. Wọ́n wá béèrè pé in this compound how many sigma bond la lè rí bẹ́ẹ̀, how many pi bonds la lè rí bẹ́ẹ̀, because I ní nǹkan apart in this covalent bonds tá mọ̀ yìí, this triple covalent bond, double covalent bond, single covalent bond, we also have what is called a sigma bond, and we also have what is called a pi bond in it. Now, wọ́n tún wá lè bèrè pé nínú compound yìí from this carbon to carbon atom bonding together, what type of hybridization it is? In this one also, what type of hybridization is this? How many sigma bonds do we have in it? How many pi bonds do we have in it? Gbogbo eléyìí in the next class la máa ṣàlàyé dára. Okay, good afternoon everyone. My name is HYBRIDIZATION and welcome to my YouTube channel. I'm here to take you on chemistry as a subject matter, then also to bring about simplicity when it has to do with chemistry, more especially in our mother tongue, Yoruba language, mixing with a little of English. And I believe you're going to see the simplicity and understanding in all the breakdown of the topics that has to do with chemistry in this process. Thank you so much. You can join me in the class to see how it goes.